Hello everyone. So today we are going to do Leetcode daily challenge, Pacific Atlantic water flow. So in this question we are given with 2D matrix, and in that 2D matrix we are given with basically height, and according to those heights only we are required to check that is that height capable enough to basically flow out all the rainwater from that particular height towards both of the Pacific and Atlantic Ocean. So this is a thing which we are required to do in this particular question, and then we would be required to return that particular coordinate and such all coordinates which are capable enough for satisfying this condition. So that would be our answer. So this was just brief I gave you. So let us read the question. But what exactly question want to say? So there is an M-cross-N rectangular island that borders both Pacific and Atlantic Ocean. The Pacific Ocean touches the left and the top edge as it is mentioned in the picture. Right? You can see that Pacific Ocean is at the top and it is also touching the leftmost, right? And for the Atlantic Ocean, it is for the right and it is also touching the bottommost. And then the island is partitioned into grids of, just a grid of square cells, and you are given M cross an integer matrix heights, where heights R, C represent height above the sea level, and all the coordinates which are being given there are according to R and C are basically represent the row and the C represent the column. Basically X and Y axis you can say, and then the island receives a lot of rainfall. So basically this is just a story time. They want to say that it receives a lot of rainfall and the rainwater can flow to neighboring cells direction, north, south, east, west. So basically they want to represent that it could go in all four directions but not in the diagonal direction. That's what they are saying, and that water could only flow if the height of the neighboring, basically we are at the present cell, then the neighboring four direction cells which are there, if the height of those is less than or equal to the current cell, because this is obvious that from where water flows. If we are at the topmost height and if there is a lowermost height, then only the water will flow, right? So that's the thing they just want to represent, or even if it is at the same height, then also it will flow. So that's what they are saying. And then water can flow from any cell adjacent to an ocean into the ocean. So basically, if a particular cell is nearby any ocean, then from that particular cell towards the ocean, that water would flow. As they are saying that they want to flow the rainwater to both of the ocean. And then what we are required to return as our answer is a 2D list of grid coordinates. Basically, we are required to return the coordinates, not the numbers which are being written at the cell. Just we are required to return the coordinates that at this particular position, means these are the positions which we can return. That's they want. So grid coordinate result, where result of I. So in that grid which we will be returning, at every index there would be two coordinates. So at every index there would be a pair which represent Ri and Ci, and that denotes the rainwater can flow from cell RICI to both Pacific and Atlantic Ocean. So to be precise, if I say you, the thing is that particular means there is some node which is basically flowing towards the Atlantic Ocean, and there is some node which is flowing towards the Pacific Ocean. That is there. Means these are either of the nodes, right? But what we actually require is, we require that it should be Atlantic and the intersection of Pacific. Basically, it should be both of the nodes. If it is both, then only that we are required to return as the answer. If it is either of them, then that won't be our answer. So that's the thing which we are required to do in this question. So let me show you further that how, I guess by this you won't be able to understand much. Let me show you the diagram only. But before that, we are required to check for the constraint. So basically the constraint M and N are there. So this simply represents that basically that M represent the number of rows which are being there and N represent the number of columns. and r which is being written there means heights of r dot length, that simply represent that at that particular row how much columns are there. And as it is m cross n matrix, right, so surely each row would be having equal number of columns. That's why we are able to represent like this. And then these m and n could lie between 1 to 200. So these constraints are in that manner, so that we could go till 10 raised to power 4 solution, that is means, and we can even go till m into n solution, or we can go till m into n whole square solution. But here the thing is that rather than going for m into n whole square solution, because the naive approach for doing this particular question is that only, means we will be checking for each node and then we will check for the condition that does that particular node satisfy that condition or not. If that satisfies, then we will be pushing into our answer, but if that doesn't satisfy, then we'll move ahead. So doing all the processing and doing checking for every node for every row or column, then because of that only it becomes m into n solution. So the thing is, avoiding that only, we are now going to do a solution in which we will pre-process the nodes, and accordingly only we will be going ahead. So, and next one this we are saying is that the height, basically the numbers which are being present at each node is up to 10 raised to power 5. But the thing is that we won't be adding, subtracting or multiplying any node, so that's why this constraint doesn't matter much here. So now let me explain you that how we can do. So here you can see that first example only which is being given there, right? So how we would be proceeding is that we will be checking for all the nodes which are being connected, means basically which are being appropriate word is like which are being connected with the ocean only, means Pacific Ocean. Then we will be starting a traversal from that, and as it is a grid, either we can do a BFS traversal or DFS traversal, both will work in the same. And as per our question also, BFS or DFS both will work. And here we are doing BFS or DFS just for the traversal purpose. And because of doing that only, we will just modify that BFS or DFS with that condition, that is our present node in increasing order or not. So that will make our question doable. That's the thing which we are required to do in this particular question. So we will be starting, means rather than, because the question says that we are required to check for nodes inside this particular, or even it could be at the edges of this matrix, but they are saying that we are required to check from inside towards the outward if we can flow out the rainwater towards both of the ocean. But how we would be doing this? We will be starting from the edges node, basically the nodes which are being connected with either of the ocean, and then we will check that could that particular node be connected to any other node, and that any other node could be connected to any such node which can flow towards the other ocean as well. That's the thing which we will be checking in this question. So that's why we are starting from the edges. And the next thing is that if we would have been checking the outward flow, then surely it would have been in decreasing order, right? Because from the higher position only we could flow towards the lower position. That's the thing. But in this question, as we are going from outwards towards inward, so now the thing would be that we will be checking for the lower node and the higher node. We'll check that from lower to higher how we can go. That's the thing which we will be doing, because it makes the same sense only, but it will make our algorithm much more easier, or else it would have been much complex to do that. Although that can also be done, but surely it would have been much complex. So that's why we will be checking in that direction. So now when we are going from outwards towards the inward, then we will be checking for increasing order, right? So that's why now our context is that we are checking for all the nodes which are bordering by either of the ocean, and then we are checking means we are comparing our present node and the next node which we will be going ahead, that is it in increasing order or not. And the traversal is basically either BFS or DFS, because both will give us same time complexity or space complexity. And basically this question could also be done with the help of DP, but in this video I'll only show you about BFS and DFS solution. So now here the thing is that we will be starting from nodes attached to either of the ocean and store them, and do this twice for both of the ocean. That's the thing which we will be doing. And then find the intersection of increasing order from present and the next node. If satisfied, then push for the further processing. So that's the thing which we will be doing. Means the thing which I had explained, that first we will be storing all the nodes in the Pacific set, and then we will be storing all the nodes which are attached to Atlantic in the Atlantic set, and then we will check that is that particular node present in both Pacific and Atlantic, and even satisfies the condition that it is an increasing order. Then only we will push that in our answer. So that's the thing which we will be doing in our solution. So after having these intuitions in mind, that these are the main points that we are required to check in this question according to the question itself. So now let us go for the code walkthrough for this particular question. Because it is simple BFS and DFS only, just we are required to do a simple tweak, and that's all because of the condition which is given, that it should be increasing or decreasing order. So now let me show you the code. So here's the code. I'll show you both BFS and DFS code. So here comes the first part for the BFS one. So in this BFS code, So in this BFS code, here it starts from this one. So it starts from this one, that so here the thing is that first we are taking this row and column, and then this Pacific and Atlantic are basically vector of vector int, means 2D vector I have taken. You can take any other data structure as well, but this vector of vector satisfied the condition, the thing which we are going to move ahead with. And even the thing is that we could also have used here map, because if we will be passing the unordered map, then it won't work, because I tried that, it was showing some sort of error. So that's why we will be required to pass then map for doing our DFS. So rather than using a map, because we don't require them to be in sorted order, right? So that's why I used vector int here, and you could use even vector boolean rather than int, but the thing is that we can do by storing 0 or 1, so that's why I have directly used the vector int. And then first thing is that we'll check that if rows doesn't exist, basically rows equals to 0, then we'll directly return an answer. Because the thing is that if island is itself not present, then there won't be any node, right? So that's why we will be passing this. Although this was not required, because as per the constraint, it is given that it will be from 1 to 200. So that's why this we can skip, but I've taken no issues for time being. So first we will be performing DFS. Actually, I've written a DFS because I was changing the DFS code, that's why. So here, first what we are doing is, we are going ahead with all the rows which are there. We will be doing the BFS on all the rows, and in that, the first thing which I am doing here is, I'm going ahead with the Pacific one, and the Pacific one is basically at this portion, right? So we are going ahead with rows, right? So that's why how I'm passing is, I'm passing for the rows, means all the rows which are being there, right? So that's what I'm passing, and I'm going ahead with the 0th column, basically this column, because this is that column which is being attached to Pacific, right? So that's why my row is R, and 0 which is there, it is my column. And then I will be passing the Pacific, in which basically Pacific will be acting as my visited array, basically visited 2D data structure it will be acting as. And then I'm passing the heights of R0, and basically this is that one which will be acting as my previous height, because for checking for the if it is an increasing or decreasing, I require my previous height as well, right? So that's why I'm passing the heights of R0, which will be presently for time being, it is the height itself which I'm passing, because it is also mentioned that it could also be equal, right? So if I'm passing the height itself, then surely it is equal, so that will also satisfy. Although this is for that condition that we require the previous height. And then here I'm having the height, basically this one. For further processing, I require that in my BFS. And then comes the next part. This is for the Atlantic Ocean. So our Atlantic Ocean is basically this and this, right? And as we are going for each row, so that's why I will be checking for all the rows, so that's why I'm passing the R, and then it would be the endmost column, right? And this is the column -1 only, right? So that's why I'm passing this, and then passing this Atlantic, which is our visited, and then our previous height, which is there, presently this height itself, and then the heights matrix that as it is I'm passing. And this was for the basically right and left portion, basically for all rows, means these rows. Now comes the part for columns, means this particular. So for Pacific, we are going for this part, right? So that's why row would be the 0th row, but the columns are changing, right? They are going this one, this one, this one, this one, and so on. So that's why columns are like this, but the row would be 0. And here in the Atlantic, row would be the last one, means basically this one. It will remain constant, but the columns would be changing. So we are going this one, this one, this one, right? So these are for the Atlantic, and like that only we will be passing our previous height, and then we will be going ahead. So this is for the starting of our BFS. So now let us go ahead that what is our BFS main logic. So here the thing is that at the starting only I have taken these as the private global variables, our row and column, then our answer, because here I'm in this particular BFS I'm not passing my answer, so that's why I've taken it as global variable, and this one is also global and this one is also global, because again I'm not passing the Pacific and Atlantic visited as it is. So that's why, because I will be required for both of them for checking the intersection, so that's why I've declared already global. And this is for the part for checking in all 4 directions, so that's why I'm taking this. And now comes my BFS part. How the BFS I would be going ahead. So basically for BFS, what we require? We require a queue, and we first are required to check that what sort of data structure we will be, means basically the type of the queue, how it would be like. So in this particular, in our queue, we are required to store row and column, right? So in that context only, we will be having the type of a queue as the pair. So that's why I'm taking the queue as pair in comment, which simply represents that the first would be a row and the second would be our column. So for starting our BFS, I'll first push the row and column into my queue, and then I'll check that while queue is not empty, then I will proceed with my BFS. So first thing would be that I will pop out my first node which is being there in my queue, means my row and column, and I'll go ahead with the processing. I'll check that if it is visited, then I'll continue, because if it is visited, then there is no fun for again visiting that particular, right? And it could also lead to an infinite loop also. So that's why I'm directly continuing it, and if it is not, then I'm marking it as visited. So basically this visited is representing that Pacific and Atlantic vector end which we had earlier taken. Basically this was for this fact only, that is it visited or not. And then if Atlantic and Pacific, if both of the visited node consist of that node, then we will be pushing that to our answer. So that's the thing which we will be doing here. So, and now next comes the part that how we will be going ahead for our further BFS in all 4 directions. So for all 4 directions, I have taken this particular directions, means going till all 4 directions. Then first I am checking for the X, and then I am checking for the Y. That's the thing I am doing. And then I am checking that if X greater than equal to, basically this is for the condition that if our what we say, if our present X, right, if our present coordinate exceeds the number of rows, it exceeds the number of columns, or it goes in this direction or that direction, then we will be continuing with this, means we will be not pushing this particular into the queue. For that fact we are taking this. Basically if X is greater than equal to rows, that simply means that it is going in this direction, right? And if Y is greater than equal to row, column, so it means it is going in this direction. Or if x is less than 0, so this simply means it is going in this direction. Or if y is basically less than 0, so it simply means that it is going in this direction. So that's why we are taking these conditions. And now comes the next part. Also we are required to check for a visited also, that if it is visited, right, so in that context we won't be taking that particular node, right, if it is visited already. Or if our height, here we are checking for ascending or descending order. So if our present height means basically our present node, if it is basically less than our previous node, right, so what that represents, that the one which was already pushed, right, so that is the greater, but this present one is lesser one, right. So we won't be taking that particular node, because we basically require all our nodes which are means if 5 is there, if basically 5 is there, then this node should be 4 and this should be 3, and then there would be ocean. But we are going towards this direction, right? So the node should be that this particular is previous node 3, right? Because it would have been already pushed. So now we are checking for 4. So basically 4 should be greater than 3, means our present node, which is this one, and this is our previous node, which is this one. So the thing is that this should be the condition, or it could be equal also. But here you can see this is our previous one and this is our present one, right? This is basically opposite to the condition which we require, right? So that's why we will be continuing, means we will not push into this particular, as if it satisfies the condition, then we will push into this particular. So this is the thing which we will be doing in this DFS solution. Now on the similar line we can do our DFS solution as well. For DFS solution everything would be same. The only thing which we will be changing is the way of calling our DFS function. You can see here that in our BFS also we were doing something like this, right? Means we were passing like this, means a DFS. Here it was written as the BFS, and all the parameters which I have written here, these were the same. Means for the row and for the column, everything is same. And here resizing which we were doing and checking for that if row exists or not, and this everything is same. You can see that. But the only thing which will change now is the way we perform the DFS. Here the code becomes smaller in size. Again, these are the same conditions which we were doing above, and now here comes the part. So basically the previous height which we were taking in the previous one, that was according to that was all just because of how we are pushing into the queue as per the direction. But here after checking for the direction, we will be pushing everything here, but the condition which is being checked, it will be checked at this particular moment of point. That's the thing which we will be doing here. Means the thing which we were writing inside this particular, now we are required to write here, and here we are writing directly the previous height rather than writing this particular R and C, right? You can see that. Means at the starting only we are checking that is that R and C less than previous height or not, and then we are checking the intersection and pushing into the same, and then we are assigning the visited node. That's the thing which we are doing here. Else everything is exactly same the way we were doing in our DFS solution. So this was all about the DFS solution. So now comes the part, the time complexity and space complexity for this particular question. So yeah, so the time complexity for this particular question is order of m into n, and the space complexity for this particular question is order of n into m. Because we can see that we are given with a matrix, and in that matrix we are basically traversing in rows and column, and for traversing whole matrix we are required to have the time complexity in that context only, because it will be in nested loop manner only. And for the space complexity, we will be storing this whole matrix at you can say in the worst case scenario, we will be storing up to whole matrix in the data structure, external data structures which we are taking. Let me close it. that is these visited ones which we are taking. At max, we can store into the same. So that would be the thing here. So that's why at max we will be having space complexity to that extent. So this was all about this whole question. If you find any doubt about the explanation or any portion, you could comment that down. And if you like the explanation, please do like, subscribe and share to your friends. So this was all for today. Thank you.